Hi, this video gonna talk about transformer. The topic that I will talk about it is magnetic coupling, construction and operation, how transformer increase and decrease voltage, type of losses in transformer, and type of transformer. First, mutual inductance. Magnetic coupling in electronic inductive coupling refer to the transfer of energy from one circuit component to another through a shared magnetic field. A change in current flow through one device induces current flow in the other device. The two devices may be physically contain a single unit as in the primary-secondary side of a transformer, or may be spread as in the antenna on transmitter and a receiver. Untraditional coupling is called cross-term and is a form of interference. Inductive coupling favor low frequency energy source. High frequency energy source generally use capacitive coupling. Mutual inductance. Mutual inductance is when two coils are located so that the magnetic flux from one coil links with the turns of another coil. The coils are referred to as coupled. The transformer of AC circuit is a common example of mutual inductance. Coefficient of coupling of a transformer is depends on the portion of the total flux line that cuts the primary and secondary winding. Ideally, all the flux lines generated by the primary should cut the secondary, and all the line of the flux generated by the secondary should cut the primary. The coefficient of coupling would then be 1, and maximum energy would be transferred from the primary to the secondary. Practical power transformer use high permeability, silicon steel core, and close spacing between the winding to provide a high coefficient of coupling. Line of flux generated by one winding, which do not link with the other winding, called as leakage flux. Since leakage flux generated by the primary does not cut the secondary, it cannot induce a voltage into the secondary. Next slide. Factor that affecting mutual inductance: air core, iron core, powder iron core, ferritic core, toroidal core, movable core, printed circuit, and board core. Air core with hollow or non-magnetic core are called air core coil. They have low value of inductance and are generally used for high frequency application. Iron core inductors use iron or alloy for a core. Large value of inductance are possible. Hysteresis and eddy current losses limit iron core to low frequency, such as power line and audio. Laminate sheet material is often used to reduce eddy current. Soft iron materials such as silicon steel may be used to reduce hysteresis losses. Powdered iron core. Powdered iron is mixed with the non-conductive binder, reduce eddy current losses. Higher current flow is possible before the inductance saturated. Ferrite core. Ferrite a good magnetic conductor but poor electrical conductor. This reduces eddy current losses. Toroidal core. Because of the shape, most of the flux flow within the core result in many little flux leakage loss. Movable variable core. These are variable inductor which can be turned. Printed circuit board core. A spiral of copper on a printed circuit board may be used as a coil. Only small inductance value are possible, which limit its usefulness to high frequency application. Next slides. Construction and the operation of transformer. A transformer is an electrical device that transfers energy from one circuit to another purely by magnetic coupling. Relative motion of the part of the transformer is not required for transformer of energy. Transformers are often used to convert between high and low voltage. to change independence and to provide electrical isolation between circuits. Most basic of the transformer consists of primary coil or binding or secondary coil or binding, a core that support the coil or windings. Next slide. Turn ratio, defined as the ratio of the number of turns in the secondary winding Ti the number of turns in the primary winding. So this is the formula: N equal to number of turns in the primary divided by number turn of in the secondary coil. Turn and voltage ratio is to calculate the voltage ratio. This proportional is expressed by the equation number of voltage of applied to the primary divided by voltage induced in the secondary equal to number of turn in the primary divided by the number of turn in the secondary. Notice the equation show that the ratio is secondary voltage to primary voltage is equal to the ratio of secondary turn to primary turn. Turn and current ratio, IP NP equal to IS NS. IP NP equal to ampere minus turn in the primary winding. IS NP equal to ampere minus turn in the secondary winding. By dividing both sides of the equation by IP NS, you obtain NP divide NS equal to IS divide IS. EP divide ES equal to IS divide. Next, how transformer increase and decrease voltage. Transformer are devices used to primarily increase and decrease AC voltage. When increase the voltage is called a step-up transformer. When decrease a voltage is called a step-down transformer. Step-up transformer, alternating current is passed through the primary coil, the input, which creates a changing magnetic field in the iron core. The changing magnetic field then induces alternating current of the same frequency in the secondary coil. A step-up transformer has more turn of wire on the secondary coil, which make a large inductance. Step-down transformer, alternating current is passed through the primary coil, which creates a changing magnetic field in the iron core. The changing magnetic field then induces alternative current of the same frequency in the secondary coil. A step-down transformer has more turn of wire on the primary coil, which make a reduced induced voltage in the secondary coil. Effect of a load. When a load device is connected across the secondary winding of the transformer, current flow through the secondary and the load. Type of losses in transformer. First, winding resistance. Current flow through the winding causes resistive heating of the conductor. Eddy current, induced current circulate in the core and cause it resistive heating. Stray losses. Not all the magnetic field produced by the primary is intercepted by the secondary. A portion of the leakage flux may induce eddy current within nearby conductive objects, such as the transformer, support structure, and be converted to heat. Hysteresis losses. Each time the magnetic field is reversed, a small amount of energy is lost to hysteresis in the magnetic core. The level of hysteresis is affected by the core material. Mechanical losses. The alternating magnetic field causes fluctuating electromagnetic force between the coil of wire, the core, and any nearby metalwork, causing vibration and noise which consume power. Magnetic friction. The flux in the core causes it to physically expand and contract slightly with the alternating magnetic field, an effect known as the magnetic friction. This is turn causes losses due to the frictional heating in suitable ferromagnetic core. Let's go to the next slides. Type of transformer. There are various types of transformer. First, auto transformer. Second, center tap transformer. Third, multiple winding transformer. Let me explain about auto transformer. In an auto transformer, one winding serves as both primary and the secondary. The winding is tapped at the proper point to achieve the desired turn ratio for stepping down or up voltage. Center tap transformer. Center tap transformer are simply defined as the transformer with a tap in the center of the secondary winding. This tap or additional connection in the middle of the winding can be used with or insert other type of connection at the end of the winding. Multiple winding transformer. Multiple winding transformers have more than one winding on a common core. They are used to operate on or provide different operating voltage. Okay, that's all.